Welcome. Today in this session we are going to discuss about data mining. It's an interesting discipline which has emerged in recent years due to the explosive growth of the data. So we all know that most of the world applications are automated, digitized. So this digitization and automation of applications has led to voluminous growth of data. So we are abundant in data and what to do with that data. So, what kind of uh, inferences can be derived from the data, from this abundant data? So these are the questions. So data mining is an emerging discipline that deals with all the functionalities to extract meaningful inferences. So to start with, we are going to discuss these topics. What is the motivation behind data mining? What is data mining? And what kind of data can be mined? What are the data mining functionalities? How do you classify data mining systems? What are the 10 most popular data mining algorithms? And what are the major issues in data mining? So what is the motivation behind data mining? So as I said earlier, digitization and automation of the world applications. So data which was collected in megabytes and gigabytes, now it's in the form of it's in the range of terabytes and petabytes. So we are abundant in data. So can say that we are drowning in data, but starving for knowledge. So data accumulation is huge. All these applications accumulate data, but how do we derive information? How do we derive sensible information from this abundant data? So that led to this particular discipline, data mining. So if you look at the major sources of data, from where do we get this data? Business, World Wide Web, all transactions are done through online. So you can make any transaction in any part of this world by just a single click in your laptop or a desktop, right? And in science, we have remote sensing, bioinformatics, scientific simulation, etc. So there's healthcare applications, agriculture applications. All applications are now automated. So every automated application generate voluminous data. So necessity is the mother of invention. So we are wondering what to do with this abundant data that led to the introduction of this new discipline, data mining. So data mining is the automated analysis of massive data sets. So we are going to discuss the various data mining functionalities and how it can be used and for what type of applications it can be used. So that is the essence of this particular course. So when you look at the evolution of the database technology starting from 1960s. So in 1960s we worked with simple databases. We will be dealing with three types of databases: network database, hierarchical database, right? And one in 1970s, the relational concept, the relational data model was introduced. So consequently, we dealt with relational DBMS implementation, and then in 1980s, advanced data models like extended relational database, object-oriented database, deductive databases, all came into existence. And 1990s, we just introduced the concept of data mining, data warehousing. So the database concept has slowly changed to a new term, that is data warehousing. Later we'll be discussing what is the difference between traditional databases and data warehouse. So if you look at the web, World Wide Web, lot of data. So it's not only text data, we have stream data, sensor data, and the web data, the multimedia, but video, audio data. So we are there are a lot of databases, different types of databases to be dealt with. In 2000, stream data management, and then we explored the data mining and its applications. So the database technology started in the year 1960 with simple database models, and now it has evolved to an advanced and robust database technology, that is data warehousing. So what is data mining? So data mining is knowledge discovery from data. As I said earlier, we are drowning in data, but what to do with data? So we need to extract some useful information. So that is knowledge. So that process. So knowledge discovery from data is termed as data mining. So what is meant by knowledge? So extraction of interesting. By interesting we mean non-trivial. Non-trivial means important. Implicit. Implicit, which is not shown explicitly, the type of knowledge. Say, if you look at a database, if the record contains an attribute date of birth, so date of birth is explicit. But from the date of birth, you can infer the age of a person. That is implicit. Right? It's a simple example, but there are so many examples how we can derive implicit information. So extraction of interesting, that is non-trivial, implicit, previously unknown. If we extract the same type of information, if we are deriving the same type of information already known, then there is no use in applying data mining. So there should be some interesting new. So previously unknown means some new novel information and potentially useful. So simply because it is new, we cannot consider. That should be useful. Right? So data mining is the process of extraction of interesting patterns or knowledge from huge amount of data. Hope you understood the process of data mining. So it can be called with different names. It can be referred to with different names. Knowledge discovery in databases, knowledge extraction or pattern analysis, data dredging, information harvesting. So many terms. They are all the terms can be can refer to data mining, the process of data mining. So if you look at this process, so data mining is the knowledge discovery from huge amount of data. If you look at the process at the bottom, you have multiple databases. So data from multiple heterogeneous databases are collected and then cleaned, because data from different sources, it may accumulate data noises. So noise should be removed, and if there are missing values should be treated. So that is data cleaning. So the cleaned data and in the cleaned and integrated data is stored in the data warehouse. So from the data warehouse, the task relevant data, that is data specific for the given application, are required for solving the given problem. So such task relevant data are selected and it is used for extracting data, useful information. So we'll be applying the data mining algorithms over the task relevant data, and the outcome of this process will be interesting patterns, some novel patterns, which we call it as knowledge. So this is the knowledge discovery process. In short, we say it as KDD. So knowledge discovery from databases. So the collection of data, data cleaning, so data integration, data cleaning, and it's stored in the data warehouse. Task relevant data is selected, which is used in the data mining algorithms, and the output will be the patterns, and the patterns are evaluated for its usefulness. Now, if you look at this pyramid, so data mining, so data sources at the bottom, it could be in the form of paper files, web documents, scientific experiments, database systems. It could be any kind of data. The sources are the data may come from multiple sources, multiple heterogeneous sources. That is important. So it's not from or the data come from files or only databases. It comes the sources of data may be different, and then it is pre-processed, integrated, and stored in data warehouses, and then data exploration is done through by querying and reporting, which is supplied to the data mining algorithms. So the output of data mining algorithms are the patterns, and they are presented using visualization techniques. Finally, based on the outcomes of data mining algorithms are based on the knowledge derived from data mining algorithms, decision will be made. So if we look at the users at each level of the pyramid, the bottommost will be database administrator who will take care of the collection and the integration of data. And data analysts, they'll be interested in getting useful information from the data. Business analysts, from the useful information from the patterns derived from data mining algorithms, they will try to utilize it for the decision making. So finally the management, the top management will be presented with the decisions. Right? So this the pyramid of data mining process. So data mining is not a single discipline. It is an integration of multiple disciplines. So we use pattern recognition, algorithm, visualization, statistics, database technology, machine learning. So we can say it is a blend of all these disciplines. So you may ask, why not traditional data analysis? So we have data. Already we are processing data using traditional data analysis. So why do you go for data mining instead of traditional data analysis? The challenges faced by the why not traditional analysis? So the challenges faced by traditional databases are tremendous amount of data. The traditional data analysis tools are not able to handle tremendous amount of data. So the algorithms must be rewritten so they should be highly scalable to handle huge amount of data in terms of terabytes. And then high dimensionality of data. So the data available now due to digitization and automation of applications, they are high dimensional data. There are multiple dimensions which could not be handled by traditional data analysis. Then high complexity of data. It's not merely text data. So data come from sensors, and then we get time series data, temporal data, structural data, graphs, videos, audios, and then data come from heterogeneous databases. It's not so normally relational databases will be used to store similar kind of data, structural data. If it's employment, it stores only employee data, right? But data mining will has to deal with heterogeneous data, right? And spatial data, it may be image data, or spatial temporal data, video, multimedia, software programs. So sources are diverse. So traditional data analysis cannot be used for diverse data types. So when you look at data mining from different perspectives, so data mining, how? So first of all, what kind of data to be mined by by data mining algorithms? What kinds of knowledge to be mined? So what are the techniques utilized? what are the applications adopted. So these are the various questions we face before studying this data mining. So what kind of data to be mined? So it could be relational data, data from data warehouse, it could be transaction data, stream data, object-oriented data, and what kind of knowledge to be mined, whether you want to characterize the given data set, that is a summarization of data, or whether you want to discriminate data, or whether you want to find the association between data types, or whether you want to classify data. So depending upon the application, the knowledge to be mined varies. Techniques utilized. What are the techniques utilized? So it could be database oriented, or the data could be in a data warehouse, or whether you may have to use machine learning, statistics, etc. And then what are the applications? It's huge. So what are the domains where data mining can be applied? It's innumerable. So it can be used in all types of fields: retail, telecommunication, banking, fraud analysis, stock market analysis, text mining, web mining, etc. So generally, data mining, the general functionality of data mining can be categorized into two types. That is descriptive data mining, predictive data mining. By descriptive data mining, we describe the data. So we characterize or summarize the features from the given data set. Predictive data mining, so given a set of data, we try to predict an unknown value. So data mining can be used for descriptive tasks as well as predictive tasks. So different views lead to different classifications depending upon the data, the kinds of data to be mined, and kinds of knowledge to be discovered, and the types of techniques utilized, and the applications, kinds of applications adapted. So based on that, the data mining application varies. So as we discussed earlier, in what kinds of data, the data mining can be applied to any type of data, starting from relational database, data streams, sensor data, time series data, object relation databases, spatial data, multimedia databases, text databases, and the World Wide Web. So, and then functionalities, multidimensional concept description. So data mining functionalities, what kind of algorithms you are going to apply to this humongous data set. So characterization and discrimination, right? So generalize the characteristics derived from the given data set, or summarize the features, or contrast data characteristics. So what are the characteristics that discriminate dry and wet regions? What are the characteristics that discriminate slow and fast learners? And then what are the frequent patterns? Suppose in a we say that market basket analysis, what are the items that are frequently purchased by a customer, right? And then classification and prediction. So classify, given an image, we classify whether it's the dog or cat. And then prediction, given the features of a house, what will be the price of a house. So likewise, so data mining functionalities can be applied depending on the type of application. So cluster analysis, outlier analysis, trend and evolution analysis, statistical analysis. So data mining functionalities is a lot. There are different types of data mining functionalities which could be applied, uh, which could be applied or selected depending upon the nature of the application. Some potential applications. So market analysis and management. Target marketing. Target marketing. Suppose if we know the buyers, say youngsters, youth. So we may, if a new cell phone is launched, then the target group will be the youth. Suppose if a new car is launched, then the potential group would be a middle-aged group and earning a good salary. So likewise, we need to identify the group, target group, and based on that, you need to market. If it is related to cosmetics, then we know the target group will be young girls. So target marketing, and then customer relationship management, how to maintain a good relationship between the customer, right, and the management. Market basket analysis, what are the items that are purchased together by a customer, or how many customers buy the same type of items, right? Likewise, so in market analysis and management, risk analysis and management, to forecasting. So it could be weather forecasting, or forecasting the price, or forecasting the stock price. And then customer retention, how do you retain a customer? Okay. Fraud detection and detection of unusual patterns, we call it as outliers. Suppose we have bank transactions. Suppose if an unusual transaction appears, like a transaction of 1 crore, where the bank transactions, yearly bank transactions are only in the range of thousands. How come a person suddenly make a transaction in the amount of 1 crore? So that is an outlier. So other applications, text mining. Say text mining, news group. So suppose we have the social media news. We can get some, what are the, suppose if a new movie is released. From the social media, we can arrive at a conclusion whether to go for that particular movie, whether it's good or bad. And then stream data mining in bioinformatics. Bioinformatics, identification of so new that is for personalized medicine, right? So the DNA sequences, identification of particular DNA sequence, or identification of particular DNA pattern that gives rise to diseases, and then personalized drug discovery. So all there are lots and lots of applications where data mining can be applied. So in this session we discussed on this session is an introduction to data mining. Why data mining? Why not traditional analysis? What kinds of data can be mined? And then what kind of applications and what kind of knowledge can be applied? What is the knowledge discovery process? Right? So we shall discuss the rest of the chapter in the next session. Thank you for listening.